1/3 or x to the 2/3 power. And you can see that that answer is there. Now you do get the same thing if you multiply the exponents first, but I think it's better to simplify inside and then apply the exponent.
Okay.
All right, we'll just go right to number 3. Number 3, okay. Which of the following is equivalent to 60 to the 1/2 power? So I previously wrote that x to the 1/2 power equals the square root of x to the power of 1. So your problem is very similar. It's 60 to the 1/2, which means it's the square root of 60 to the power of 1, or what most students would just write the square root of 60.
Okay, so the 2 doesn't have to go there because that's what the square root means anyway.
The square root means 2. It's kind of like saying your ear that you have side ears, even though our ears are already on the side of our head.
So this is concerning. The last 3 problems have been answer B. That never happened.
When they're auto-generated, that is entirely possible. If a human was doing that, we would be worried about that. So if you're interested in probability, I mean, it's the question should be independent, meaning one doesn't affect the other. So okay, let's actually jump to 5 first before we dive into negatives and exponents. A lot of confusion there in general. So let's go to 5, because 5 is a nice continuation of kind of a previous problem here that we were looking on. So I mentioned earlier that like you could literally apply this 1/2 to everything. You could apply to those 3. You can multiply. Or you can work on what's inside. And I think that's a better strategy. I think it's better to take what's in the numerator. Okay. And when the bases are the same, you add the exponents. 5/4 plus 1/4, which is 4 to the 6/4, which is 4 to the 3/2 power. The denominator, well, it's 4 to the 1/2, and we'll just scoot that over here. It's 4 to the 1/2. So when the bases are the same and you're dividing, you subtract the exponents.
Oh, okay.
So here's an exponent rule. And let me just go up here. I mean, here's another. These are all available out there in various reference sheets. You definitely got to have all these down or have them on a note sheet, reference card, whatever you get for your exam. So in this problem here, you're gonna subtract the exponent. So it's 3/2 minus 1/2, which is 4 to the 2/2, which is 4 to the power of 1. Right?
Yeah.
So notice, like we just did everything inside the parentheses. So this 1/2 carries down. Like the 1/2 is still part of the entire problem. We just sort of neglected it to the 1/2. So this is 4 to the 1/2 power, which is the square root of 4, which we know to be 2.
Oh, yeah.
Which is nice. It works out really, really nicely. All right, so I'm just looking ahead here. Let's try number 10 next.
Okay.
There is a method to the madness here, the disorder. Okay, which expression is equivalent to 125 squared over 125 to the power of 4/3? So notice again, the bases are the same. It's this x to the n over x to the m, which means that you subtract the exponents. So it's going to be 125 to the power of 2 minus 4/3. 2 is really 2 over 1. So when we make a common denominator, it becomes 6 over 3 because you multiply the top and bottom by 3. And that gives you 2/3. So that's 125 to the power of 2/3. Is that okay so far?
Yeah.
Okay. Now the way we would rewrite this, and just this is a good one, is it's the cube root of 125 squared. Do you agree with that?
Yeah.
This is correct, but it's not the right path to go. You know, like if you're taking a road trip somewhere, you know, this is like the indirect path, and we'd rather just take the straight one there. So to do that, we have to look at this number here, 125.
Mhm.
Okay, now 125 is a base to an exponent, and it's a known one.
I don't
So
really understand what you mean by that.
okay, yeah. So for example, actually, let me go grab it. I'll send you the link here to it. We're doing great on time, so a little slight diversion here to show you this. Just grab this reference sheet real quick. Actually, exponent table. All right, copy link. All right, so I'm gonna throw this in the chat, and then I'm also gonna just snip in the table so that you can see how to use this. Sorry, just getting to where I can find the stuff that we need. All right, learning. Stop, come on. There it is. Okay, so the exponent table here, there's a bunch of these that I tell students, I say, these are good to know. Like these are kind of thing that if you can remember quickly, it will save you time, especially on standardized tests. So I know a bit of a diversion here, but this is important. So for example, 5 to the power of 3 is this entry right here. 5 to the n, where n is 3. And so the idea is that you're supposed to recognize both directions, like, hey, 125 is really 5 cubed, 5 cubed is really 125. Okay, so I'll probably be referring to this for the next few questions, but I want to just throw that at you to start here. So 125 up here. Okay,
Mhm.
and actually let me just go down. Kind of, I know we got a lot going on in this, so let's just restart. So 125. Grab this centered here, is really 5 to the power of 3. And if, as you recall, when you have an exponent to an exponent, you multiply them.
Right.
So what is 3 times 2/3? Well, it's 3 over 1 times 2/3. It's, well, the 3's cancel and you get 5 squared, which is just 25.
Okay.
Is that okay?
Yeah.
Okay, so let me go back to your assignment and continue with that. So I want to go to, yeah, let's go to 7. 7 will make a lot of sense now that we have looked at that particular problem. So let me go to 7. Okay. All right. So this is kind of the same deal. You know, what you could do, and you know, this isn't wrong. It's just not preferred. Is you could say, well, what's the 4th root of 16 cubed? And to me, this is like spaghetti. It's just way more confusing. But 16, if we go to that reference sheet, so another way you can use this reference sheet is you can just look for the number inside there. So 16 occurs in 2 places, here and here. It's either 2 to the 4th or it's 4 squared.
Okay.
Okay, so which one? Well, the answer is it depends. So 2 to the 4th to the 3/4 or 4 squared to the 3/4. Okay, so again, but you're going to multiply the exponents. So in the first one here, it's 4 over 1 times 3 over 4. That's nice because the 4's cancel and you get 4 to the power of 3. On the right here, it becomes 4 to the 2 over 1 times 3 over 4. And that's not as nice because you end up getting 3 halves. we like when it's a nice number to a number where they're both integers. So 4 cubed is 64, and I believe that's what you're looking for on this one. So again, sometimes the answer kind of clues you into what which way they want you to go.
Right.
Because on a standardized test, this one on the right could also be there, just to be deceptive, to be sort of like, hey, we're going to be a little bit different. Let me know when you get caught up and we'll move to the next one.
Okay, caught up.
Great. All right, so which expression is equivalent to? So they're basically all sort of the same setup here. This is the one where you can apply the exponent to each of the exponents. So 256 has an exponent of 1, even though we don't write it, but it is there. And then it's x to the 16th times 1/4. And again, the reason I chose to do it this way is there's nothing to simplify inside parentheses. Whereas in that previous problem, we would have like x to the 1/3 times x to the 4/3, squared. Well, we would want to deal with what's inside parentheses first. But since there's nothing to do in here, we'll just leave it like this.
Mm-hmm.
Okay, so the one on the right, 16 times 1/4, or 16 divided by 4 is 4. On the left, you've got this same situation that we had in the previous problem, where you really need to write this 256 as a base to an exponent.
Okay.
And that's where this table really is handy, because if you spend just a little bit of time looking at it, you say, oh yeah, there it is. It's right there. It's also there. Okay, and that's the line. So it's either 4 to the power of 4, 4 to the n, 4 to the power of 4. You just find the intersection of the two, or it's 2 to the power of 8.
Right.
And which one is it? Well, it depends, right? Actually, either one would work here, because it's 256. So it's either 4 to the 4th to the power of 1/4, or it's 2 to the 8th to the 1/4. And both of these work out nicely. You see that they're both 4.
Yeah.
And that was true in the previous problem. They were the same, even though they were presented differently. They were exactly the same numerical value.
Okay. Oh, now I see the answer.
Yes. Yes. Oh, sorry. Yeah, I got way. It's 4x to the 4th. Yeah, there it is. X to the 4th. Sorry, 4x to the 4th. If I'm ever unclear on that, just
No,
ask.
okay. I just had to remember what the exponent was for that.
Yeah.
I mean, there was only 2 4 ones, but.
Okay, we're gonna move back to 30. Sorry, to 4. Okay, and there's just a little wrinkle to this.
The negative sign.
The negative. And what I want you to do is just ignore it for the moment and be like, all right, how do I do 32 to the 3/5 power? Okay, and then we'll talk about do the negative. So go to that table if you've got it handy. If you don't, I'll snip it in. But we really want to write 32 as some number, some base to some exponent. Do you have that?
See 2 to the 5th power?
Perfect. Now, the reason we know that that's good right away is because this number is a multiple of 5, or in this case, it's perfectly divisible by 5. Because it becomes 2, 5 over 1 times 3 over 5. The 5s cancel, and you get 2 to the power of 3, which is 8. Now, that is if there's no negative. Okay, but it was written as negative 32, 3 to the 5th. So what I need you to see and realize is that this is really -1 times 32, 3 to the 5th. And the reason I'm showing you this way is because that 3 to the 5th applies to the 32, not to the -1. It does. Sorry, I put that in the wrong place. It does not apply to that. Nope. Just to the 32.
Okay.
Okay, but not to be confused with, let's just say it was written like this, then it does apply to this.
Right,
But
if
what's
it
the,
was in parentheses.
but in parentheses? So parentheses tells you it's like whatever's inside parentheses is treated all together.
Mhm.
You can't see it, but I started talking with my hands. And I realized you can't see that. So
It was funny. I was talking with my hands. Apparently, I was talking to my mom, and she had me do something, and I stopped talking because I couldn't move my hands. And she's like, "I can't believe that you can't talk unless you move your hands." I'm like, "I never realized it even."
a lot of communication is nonverbal. So it's it's a wonder we are even able to communicate if we don't have the ability to see one another. That's good. That's good. All right, so we got question 8 and then 9. I know we got 8 and then 9. This is the only negative exponent. I guess I thought there would be more because these are the ones that really mess up students when they're learning this. So here's the property. If you have a negative exponent, you put
I'm
it.
sorry. I'm so sorry. What was the answer for the last question?
8, -8. Sorry. Thank you. So that negative just comes in front. So it's negative, 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 negative.
Oh, yeah, okay. That makes sense. Okay. Thank you. Sorry.
Okay, so are you ready for this? Is that okay?
Yeah.
So what you do is you put it on the bottom here.
Okay.
So let me give you a better example. Let's say it's 5 to the -3. It becomes 1 over 5 to the power of 3.
Okay.
So somehow you have to like convince yourself that all you do is to interpret or deal with the negative is you go to the bottom. So it's 1 over 36 to the 1/2 power.
Okay. And then we have to simplify
Yes,
that.
yes. So this becomes 1 over the square root of 36. Which is
Okay.
1 over 6.
The only one I believe we have left is number 9.
Yes, yes.
I don't know if you'll understand number 9, but I don't.
Yeah, it's it's believe it or not, this is a physics problem. It's Kepler's laws of motion. Kepler studied the motion of the planets, among other things. So the equation that you care about is t squared equals a cubed.
Okay.
And it says if planet Y is twice the mean distance from the sun. So we got to figure out which one is. So t is the distance. And a is these units, astronomical units, which aren't all that important. But it's telling you it's like say, well, t goes to 2t.
Okay.
So all you're doing here is you're putting 2t in for t, squaring it. And you're dealing with the you're now solving this for a. So it looks more complicated. You have to square 2 and square t. So you get 4t squared equals a cubed.
Okay.
I'm sorry, I gave you the wrong. I'm sorry. We need to start again. I gave you the wrong. I did this backwards. Okay. T squared equals a cubed. And t is the orbital period. T is the period. And a is the distance. Okay, so they're saying the distance increases to 2a. So you take 2a in here, and you're solving this. So not solving this, you're simplifying this. So it's 2 cubed a cubed. So you're cubing both of these. So that's 8a cubed. All right, and then why are the answers the way these are?
That's what I'm wondering. Because
Yeah.
I'm not really sure how you're supposed to simplify it beyond what you have.
So you're supposed to build this proportion to the previous one, but the a cubes cancel. So my guess here is that it's going to be, if we look at this as 2 cubed, okay, a cubed, and then we take a square root of both the sides, or 1/2 of both sides power. You get 2 to the 3/2 because you multiply in.
Oh, okay.
And I would guess that is what it's looking for there.
Oh.
Although I don't feel like that explanation is great, but it's the kind of problem you may not see again. I mean, it's really out of scope here for this class.
Yes, it's really, we don't usually have this wordy of problems. Okay.
All right, so we have some time left. Would you like me to give you more problems of each type?
Yeah, well, except for the one we just did.
Yeah, of course. Yeah, of course. Okay, so I'm just gonna go back, and I'm gonna do a problem like number 1. Okay. So we'll go. So do you have the ability to go back to number 1?
Yes.
Okay. All right. So I want you to try and simplify this problem here, please. And please refer to your notes from number 1. It's just change numbers, the same process.
Okay, so I got x to the 4th power and in parentheses y square root the 4th. I don't know how to say it.
So let me write it, and then you tell me if so. We would read this as the 4th root of 4.
Okay.
But that's not important. I mean, this isn't an oral math class. This is did you write it down, or did you check the box?
That's what I wrote down.
Perfect. Do you want another one like this, or do you feel like you understand that?
Yeah, I think I got that one.
Okay. All right, so let's do another one like number 2. Let's go x to the, let's go 3/7 x to the 9/7 to the 1/4 power. Give that a try, please.
Okay, I got X. The exponent is 3/4.
Okay, let me work it out here and just see if sometimes when I ask you to do that, I know it's not the best because it's hard to follow here a little bit. So it's x to the 12/7. Okay, but then it's to the 1/4 power, right? Do you remember that? Just bring that down.
Yeah.
Now you multiply the exponents, so you're going to take 12/7 and you're going to multiply it by 1/4.
Okay.
Now, this one's slightly different. The 12 and the 4 they do cancel. You get a 3 up there. So this is x to the 3/7.
Okay, so I didn't do it right.
Okay, let me give you another one here to try, and just take another opportunity here to see if you can get it right. X to the 7/3 to the 1/2 power. Okay, give that one a try, please.
Okay. Okay. This time I got X to the 4.
4/3. Yes, perfect.
Oh,
Okay.
yeah.
Now, how would you write it with a root? So tell me the number that goes in position A and in position B.
Position A is 3.
Yes. And B is
4.
perfect. Good. That's good to know. Good to know. All right, let's move on to, we're gonna skip 3 because it's not a great problem to replicate. So we'll go to 4 here. Let's try -125 to the 2/3 power. 2/3 power. So take a look at your notes for number 4. Sorry, number 4. I might have said 5. And just see how we worked that out. Try to remember what we did with the negative and then how we handled that number there.
So I got 25.
Very close. What about this right here?
Oh, I forgot the negative.
Yeah, that's the
Sorry.
problem. That's the problem with me. The way I explain it to you is yeah, you do ignore it, but it does, it comes back at the end.
Yeah. Yeah.
All right. Good. Now it doesn't always work out nicely. Like I could give you -32 to the 3/8 power. And so, for example, there's a lot of options here. Like 32 could be 2 to the 5th to the 3/8 power.
Mhm.
And then you multiply the exponents, so you get 2 to the 15 over 8.
Right.
I mean, that's your answer. That's correct. But it's not like
Okay.
sometimes they do work out nicely, sometimes they don't. That's why they're there.
Right.
Okay, so let's look at number 5 now. See if I can come up with one here. 6 to the 4/3, 6 to the 1/3 over 6 to the 2/3, all to the power of 1/2. Actually, let me make it 1/6. Let me change that. There you go. That looks good. I'm going to step away for 30 seconds, but I'll be right back.
Totally fine.
All right, I'm back. How are you doing on this one?
I got confused.
Okay, so let's look at the numerator. Did you add 4/3 plus 1/3?
Yes.
So that is 6 to the 5/3.
Yes.
And then the denominator is 6 to the 2/3.
Mhm.
So you subtract those 5/3 minus 2/3,
Right.
which is, what does that become?
That becomes 6 to the 1 power.
Yes. And then it was all to the power of 1/6.
Yes. This is where I got confused. I'm not really
So,
sure what to do.
so this is the answer. And I kind of,
Ah,
it's just that it's 6 to the 1/6, or it's the 6th root of 6.
okay. Because
Both
I
are
got
correct.
confused if the ones like cancel out and then 6 to the 6th power.
So it's 1 over 1, right? 1 over 1 times 1 over 6 to become 1/6.
Okay.
All right, let's do, oh, good. So number 6, we can do a bunch of problems like this. You'll definitely want that, that sheet that I had
Yes.
mentioned. I'm gonna pull from that a few. So let's go 343 y to the 18th to the power of 1/3.
Okay. So I got 7x to the 6th power, or
Yes.
7y, sorry.
Perfect. Good. Yeah. So that problem is designed to always kind of work out nicely. It doesn't have to, but it can. So let's look at number 8. We'll keep some really simple problems like number 8. So what is 4 to the -1/2 power? And really look carefully at your notes for what to do with that negative exponent. That's really the key here to this problem.
So I got 1/2.
It is definitely 1/2. Perfect. And like 81 to the -1/2 would be 1 over the square root of 81, which is 1/9.
Okay.
So pretty good here. Yeah. So just to review here, I don't want to do any more problems here, but just the properties we use today. So if you have an exponent to an exponent, you multiply them. You might even write that out, multiply. If they have the same base and you're multiplying, you add them. When you're dividing, you subtract, right? And then it's sometimes written like this. If you have n over m, it's m over n. It's the nth root of x to the m. And this is kind of the summary of the properties that we did today. All right, Emma. Well, that does take us to the end of our lesson for today. I'll send you the notes here shortly. If you have time, definitely recommend retrying some of the problems we did, but we did almost one extra of each.
Yeah.
And look forward to helping you next time. So I hope you have a great few days off here with your weekend coming up.
Yes, you too. Thank you.
You're welcome. Bye now.
Bye.